Hey everyone, my name is Nikayla Godson, and today I will be teaching you how to find the pH of a diprotic acid. The question asks, what is the pH of a 0.100 molar sulfuric acid solution? It advises me to be considerate of all the sources of H+. This advisory comes from the fact that sulfuric acid is a diprotic acid, meaning that it has two sources of the H+ ion, thus it will have two dissociations. The first dissociation will be of the strong acid, sulfuric acid, which dissolves completely into the H+ and the HSO4- ions. Because it dissociates completely, it will have the same concentration throughout of 0.1 molar. Now we have to show our second dissociation, which will be of the weak acid HSO4- into the H+ ion and the SO4- ion. Because this is a weak acid, we will have to find the H+ concentration through a Rice table. We already have our I, which will be our initial concentrations, is 0.1 molar for both the HSO4- ions and the H+ ions because we found that from before. SO4-, however, will be 0. C, which is change in reaction, will be for every mole of HSO4- consumed, that will be negative X. For every positive mole of the H+ and SO4- ions formed, those will both be plus X. Thus, we can now say that our equilibrium will be 0.100 minus X for the HSO4-, and it will be 0.100 plus X for the H+, and X for the SO4-. Ka for this will be 1.2 times 10 to the negative second. With all these values, we can now set up our equilibrium expression. We know that Ka is equivalent to products over reactants. Thus, that translates into H+ times the SO4- ion all over the HSO4- weak acid. We can now plug in our values of 1.2 times 10 to the negative second, which will be equivalent to X times 0.100 plus X all over 0.100 minus X. At this point, we will have to rearrange our terms in order to solve for the A, B, and C terms for our quadratic formula. Over here, for time's sake, I will briefly show the math that was done in order to solve for this, but essentially you're just doing a bit of algebra to set your equation up to 0 so that you can have your A, B, and C terms isolated. With that, now you can find your quadratic formula in order to get X, and so once you do that, you know that the quadratic formula is X equals negative B plus or minus the square root of B squared minus 4AC all over 2A, which we will plug in our A, B, and C terms over here on the right. And what you end up finding is that X is actually equivalent to two terms, but it can't have a negative concentration, therefore X is equivalent to 0.00121. So now that we have our X term, we can finally use that in order to find our H+ concentration. We know from our Rice table that H+ is equivalent to 0.100 plus X, which is thus going to have to add the 0.00121 that we found from our quadratic formula to the 0.100, and when you do that, you end up with 0.101 for the H+ concentration. With that, we can find our pH, which will be the negative log of the H+ concentration. Since we know that that concentration is 0.101, we can find our pH, which will be 1. So overall, remember that sulfuric acid is a diprotic acid, and that for any diprotic acid, it will have two dissociations, the first of which will be the strong acid, and the second of which will be the weak acid. Whenever you're dealing with weak acids, you need to set up a Rice table in order to find the concentration that will represent both of these sources of the H+ ion, which you will then use in order to find your pH once you take the negative log of that. The in-between steps involve some algebra rearranging to get your A, B, and C terms and solving for X through the quadratic equation. Just remember that you can never have a negative value for X or a concentration for X that was bigger than what you were initially given. And overall, once you solve for this, you should have your pH that considers every source of the H+ ion that would come from a diprotic acid. Thank you.